Okay, welcome along to the 2017 June Paper 5 non-calculator higher tier walkthrough, and we'll go through the whole paper. I'm going to really, as always, try and show all my thinking for all the questions, so probably quite a long video, but of course you go to the questions that you need to. But definitely, when you go through this, you've got to practice it without using a calculator for Paper 5, okay? And without further ado, let's begin. Question 1, you've got to work out 2/15 times by 15 over 22, give your answer in its lowest terms. Now here, we want to be able to do this efficiently. We've got to recognise that you can cancel the 15s up here and down here because it's cross cancellation. You're timesing, so you're simply going to be left with 2 over 22. Okay, because these guys here, they cancel, so you've got 2 over 22 left over. Now from here, you can simplify a little bit further because you know that 2 and 22 are factors of 22, so you can go and divide by 2. 2 divided by 2 gives you 1, 22 divided by 2 gives you 11. So I believe that is our answer. Check the mark scheme. Yeah, we are correct. So 1 over 11, okay, is your fraction in its lowest terms. And that is 1 mark to get us underway. There we go, 2 marks in the bank. Question 2 looks like a distance time graph. You've got the graph shows Mia's journey from her home to university. Okay, so you've got this. Calculate Mia's average speed for the whole journey. Okay, so we're looking at speed, distance, and time here. So definitely I recommend we're going to draw out our triangle for speed, distance, and time. So here we go. Bam, bam, bam. There we go. Good. And then we've got speed. So S down here. So speed. We've got distance up here. Okay. And then we've got time down here. Written not particularly neatly, but hopefully you can see that. Now we're trying to get Mia's average speed. So speed, put your finger over this part, is going to be distance divided by time. So let's make a note of that. Speed is going to be equal to your distance divided by time. Now Mia's total distance, so she started at 0 kilometers and she finished off at 160. Okay, so the total distance must be 160 kilometers, so 160 kilometers. And it's important to put the units here because well, you can see it down below. You want the speed in kilometers per hour. So we've got kilometers, which is good. And we're dividing by the total time taken. Now, the time taken, you've got to go and do it in hours because it's kilometers per hour. We start at 9 o'clock and we finish over here. Well, these increments are going to be 9:15, 9:30, 9:45, 10. So we're going up in quarters of an hour. So if that's 11, that must be 11. Quarter past 11, that must be 11:30. Okay, so in total, right, from here to here is 2 hours, and then you've got another quarter of an hour, another half an hour. So this is 2.5 hours. So your time is going to be 2.5 and then hours. Okay, and now this is a non-calculator paper, so you've got to do this without using a calculator. So what I would recommend you can do here is I'm going to actually go and upscale this by timesing the 2.5 by 4 to give me a nice 10. I must do the same thing on the top. Okay, so I'm just sort of simply manipulating the fraction. So I'm going to be getting 160 times by 4 is going to be 640. So 640 divided by 2.5 times by 4 gives me 10. Okay, so 640 kilometers divided by 10 hours. The zeros here are going to cancel. Bam, bam. So you've got 64 divided by 1, which is just going to be simply equal to 64. And then you've got kilometers per hour. So kilometers per hour. And this is my answer for the question. Okay, so I can't actually see the bottom of the screen, but I put in 64 kilometers per hour. Question 2, there we go. Perfect. So that is 3 marks, in the bank. Good. Question 3. You've got last year Kate earned £16,200. Her total loan repayments were £6,400. Okay. Kate estimates that the ratio of her loan repayments, so this part up here, to her earnings, so the top part, is approximately, so roughly equal to 3:8. Is she correct? Let's highlight a few keywords here. So we're looking at the ratio of her loan repayments, which is this one over here, which is £6,400 to her earnings, which is £16,200. Okay, so I'm going to go and call loan repayments. Let's go and call this one just L, loan repayments, and then earnings E. So we've got the ratio of the loan repayments to the earnings. Now, so that's going to be the ratio 6,400 to the earnings, which was £16,200. Now, we've got to go and simplify this, and it should be roughly equal to 3 to 8. What you can do straight away is just knock off these zeros. They're going to cancel off, so these are going to cancel by dividing through by 100. So you've got the ratio left over of 64 to 162. And now I'm going to go and divide by a common factor. They're both even, so a good place to start here would be to divide both of these by 2 now. And that's going to give me 64 divided by 2 gives me 32 to the ratio 162 divided by 2 is going to give me 81. There we go. Now, I can see this is going to be pretty close to this here. Now, if I go and divide both of these here by 10, okay, you're going to see even more clearly, if I divide these by 10, we get the ratio of 3.2 to 81 divided by 10 gives you 8.1. And you can see really clearly that 3.2 is approximately 3 and 8.1 is approximately 8. But just to give a bit more reasoning here, we can go and say something like this. If I go and type up an answer, let's go and get a bit of my, how do I get this up? There we go. So I'm going to go and say that 3.2 to 1 decimal place is 3, and 8.1 to 1 decimal place is 8. So yes, she is correct. So it's really important that you do give your final statement just to get those extra marks, or the extra mark at the end. Good. Okay, so that's question 3 done and in the bank. Question 4, you've got this. Rashid invests money into an account which pays a fixed rate of compound interest. So this here is like the compound interest formula. You've got your initial amount times by the multiply to the number of years. The value V pounds of his new investment after 2 years is given by the formula. How much money did Rashad invest? Well, that's going to be when the time was equal to 0 years. So when he put money into the bank account was when it was when he first did it. So at time equals 0. So put this into your formula. V is going to be 1250 times 1.03 to the power of 0. Now this here, anything to the power of 0 just gives you 1. So it's going to be V equals to 1250 times by, this will just give you 1. So equal to £1,250. Okay, and this is your answer. That is the initial amount of money he put into his bank account. It says, what rate of compound interest is paid each year? Okay, well, this 1.03 here, this is what you call the multiplier, okay? And if you're multiplying by 1.03, percentage multiplier, that is a 3% increase. So the rate of compound interest each year is going to be equal to 3%, 1 mark in the bank. So this is compound interest, this topic. Circle the graph that best represents the growth of Rashid's account. So you've got a linear graph here, and then these two here are exponential. Now it's definitely not going to be linear, because if you've got anything to a power, it won't be a straight line. So definitely not the first one. So it's either going to be this kind of rising exponential curve or this one, but because your start value is 1250 and not 0, it must be the last graph. So circle the graph that best fits the equation. It's going to be this one over here. And that's going to give you the extra mark, because this point here will be 1250, and you've got this kind of rising exponential growth. So anything to a power will give you this exponential kind of growth, as you can see here. Good. Question 5a, rearrange the equation to make x the subject. So you want to get x to be equal to something on its own. Now here you've got 7x take away 3. A good place to start here would be to go and add 3 to both sides of the equation. Let's go and add the 3 over here. Add 3 to my left hand side also, because then these are going to cancel, they make 0. So on the left hand side you've got y plus 3, so y plus 3 being equal to, these guys have gone, and you're left over on the right hand side with just 7 and then x. Now you've got 7 times x, you want x on its own. Let's go and divide both sides through now by 7, divide by 7, divide the whole left hand side also by 7. Of course, these guys here are going to cancel. So x is going to be equal to y plus 3 divided by 7. Okay, and that's your answer. So y plus 3 over 7, and that is 2 marks in the bank. Check the mark scheme, all good. Okay, this one here, you want to factorize x squared, take away xy. So what can you take out from the first term and the second term? Well, you can go and take out an x, because you've got those in both terms. Open up a single bracket, okay, and then you can go and think, well, x times what gives you x squared, x times x gives you x squared, and x times by minus y. Okay, so if you go and do x times it by negative y, you get negative xy. So you factorized it, you've put it into a single bracket. There we go, okay? And that is simply going to be your answer for this one. Now this here, if you're factorizing this is a quadratic in the form ax squared plus bx plus c. You've got 3 parts to it, okay? And because the coefficient, the number before the x squared, it's just a 1x squared, this is a easier variation to factorize. The way that you do this, well, first of all, it's going to go into a pair of double brackets like this, okay? And because you've just got an x squared for your first term, it's going to be an x at the start of the bracket and an x here. Now, the process for this, you need numbers that multiply to give you the last number, which is positive 12, so times to make 12, and that add to give you the middle number, which is positive 8, so 8 can go in here. Now, these numbers are going to be 6 and 2. And let's just double check it, because what is 6 times 2? 12. What is 6 add 2? It gives you 8. So your numbers are going to be x plus 6 and x plus 2. Okay, so this here and this down here, they mean exactly the same thing. Okay, you've just put this here into a brackets, i.e. you factorized it. So x add 6 and x add 2. This is your answer. Let's go and fill this in. So x plus 6 and then x add 2. There you go, another 2 marks in the bank. Good. Question number 6. Bit of a wordy one. Jenny plays 4 games of golf. For these games, her modal score, okay, so the most was 76 and her mean was 75. Her range was 10. Let's highlight some keywords here. So she played 4 games of golf. Her modal score, the most was 76, and her mean, the average, was equal to 75. Okay, good. What were her scores for the 4 games? Now, straight away, right, we know that the mean, okay, was equal to, I'm just writing down what I know, the mean is equal to 75. Now, we know to get the mean, it's going to be the total of everything added up. You divide it by how many numbers there are, which is 4. Okay, as you can see in the question, 4 games. So your total, you'll divide it by 4, and that equals the mean, which is equal to 75. So to get your total, you can do 4 times 75. Okay, your total is going to be equal to 300. So your numbers, they must add up to make 300. Now, if the modal score was 76, you've got some options here. You could either have 76 twice, okay, so you could have 76 and 76, or you could have it maybe 3 times, okay, 76, 76, and then 76. You couldn't have it 4 times, because if you did 4 times 76, it would go above 300. Okay, so it's either going to be this one or this one. Now, if you chose 3 options, okay, let's see, it's not going to be this one, I can see, but let's just show you why. If you add these together, okay, you're going to get 7, 14, 21, 228. So these are going to add together to make a total, if you add them, of 228, which would leave you from 228 to 300. That's going to leave you a difference of 72. So that would leave you a difference, if we take away it from 300, okay, that's going to give you a difference of 72. Now, the issue is here that the range of her scores was 10. Well, if these were your scores, 76, 76, 76, and 72, they do make 300. The mean would be 75, but the range here is clearly not 10. The difference is only 4. So it cannot be these 3 over here. No way. So it must be, the mode must appear twice. Now, if we go and consider this, let's go maybe over here. So we're going to go in kind of a bit more room over here. Let's go and do it in red still. Sorry, it's gone a little bit messy. Okay, so let's just go and put a bit of a divide down here. So now I know for sure that we're going to have 76 occurring twice for sure. And if we add those together, you're going to get a total of 152, which means from your total of 300, you can have a difference left over of 148. Now, so I'm going to go put here, you've got 76 for sure, you've got 76, and then you're kind of going to have a higher number and a lower number down here. And we know that this number and this number, they must add up to make 148, the remaining total. So we can go and say that your highest number and your lowest number must make a total of 148, but also that the range is equal to 10. So you can also go and say that the biggest number take away the lowest number must equal to 10. Actually here you've got a pair of simultaneous equations, okay? And these are quite nice to go and solve. If we go and call this equation 1, call this equation 2. If I go and add these together, these guys here are going to cancel. So if I go and do equation 1, add equation 2, we're going to get 2h here, they're going to cancel, is going to be equal to 148 add 10, which gives you 158. So to go and get h, divide 158 by 2. So h is going to be equal to 158 divided by 2 is going to give you a value of 79. And of course, now to get the lower value, okay, you can go and put it back into this here. So let's go and do that. So let's go and put it into equation 2, because why not? Your highest value, which is 79, take away the lower value, it must equal to 10. Therefore, your lowest value must be equal to 79, sort of take away 10, which is going to give you 69. Okay, so your lowest value must be equal to 69. So there we go. Right, we can go and replace now these guys here. Okay, so the highest value we can see was 79, and the lowest value was 69. Put it into there, and there we go. Okay, let's check it makes sense. Is the modal score 76? Yes, it is. It occurs the most. Is the mean going to be 75? It is. If you add these together and divide it by 4, you're going to get 75. And is the range 10? Well, the smallest, 69. The biggest is 79. Yeah, the range there is definitely going to be 10. So these are my numbers. Okay, quite a nice question actually, that one. 4 marks in the bank. Question 7, a ratio question. The population of a village is in the following ratios. So men to children and women to children. So a bit of a classic double ratio question. Let's write things down. I'm not even going to read the question, but I'm just going to write what we've got. So we've got the common thing here is children in both. So that's going to go in the middle. And you've got, first of all, you've got men to children is in the ratio 11 to 3. There we go. And you've also got women to children is 5 to 2. So let's go and put woman over here. And woman to children, so woman and then children, so woman is 5. So also we've got 5 to 2 down here. Okay. Find a ratio of men to women. So basically you want to go and get the children part to be the same, and then you can compare all 3 parts and then get a ratio of men to women. So 3 and 2 both go into 6. So let's go and multiply the first ratio by 2, and the second one, let's go and times that one by 3. If we do this, okay, 2 times the first one, so 2 times by this, we're going to be getting 22 to 6. And if we go and times this ratio by 3, well, 2 times 3 gives you that 6, and 5 times 3 gives you 15. So there we go. So now you've got the ratio of men to children to women, because for every 6 children, there's 22 men, and for 6 children, there's 15 women. You want the ratio of men to women, so you want this part, men to women, which is 22 to 15 in its simplest form. Well, you can't simplify 22, and you can't simplify 15. There are no factors of 22 and 15 other than 1. So I believe that's going to be your answer. Let's check the mark scheme. Good, this is my answer. So perfect. Part B is this. There are 36 children in the village. Find the total population of the village. So a bit of upscaling here. Okay, we know that the ratio of men to children to women from the first part is 22 to 6 to 15. And it tells you that there are 36 children. Okay, so we can go and put under the children part, you've got 36. There we go. And then we can go and upscale here. To get from 6 to 36, you are multiplying up by 6. Okay, you're timesing through by 6. So therefore, 22 times by 6 is going to give you, let's just double check this. Don't make any silly mistakes. So 22, we're timesing it by 6 is going to give you, 6 by 2 gives you 12. 6 by 2 gives you 12, you add the 1, 132. Okay, so you've got 132 here. And 6 times by 15 is going to give you 90. So the total population, okay, is going to be equal to this, add this, add this. And let's just use a column method here so we don't make any mistakes. So you've got 132, add 36, add 90. Okay, let's just give a bit more room. Let's go and add all these up. Okay, so 2 add 6 gives you 8, 3 add 3, 6 add 9, 15 goes down here, and then 1 of 1 is going to give you 2. So hopefully 258. There we go. And that is our answer, checking the mark scheme correct. So in total, you've got 258 people, and that gets you the marks there. Let's zoom out so you can see the whole question. Okay, and there we go. Good. Question 8. Straight away, when I look at this, right, I can see polygons here. So I'm going to just get down the 2 formulas that you need for polygons, because you might not need any of them, or you might need one of them, but it's just going to be useful to make a note of them. So we know the 2 formulas for polygons is the sum of the interior, so the total of all the inside angles is equal to n, take away 2, times by 180. That's your first formula. Okay, we might need it, we might not need it, but let's make a note of it regardless. And the size of one exterior angle in a regular polygon is equal to 360 divided by n, where n is your number of sides. Okay, so these could be really useful. Okay, and the question is saying this. Oh, sorry. The question is saying, Imran joins 2 tiles together, as you can see. One tile is a regular hexagon, so this one has got 6 sides, and the other is a regular pentagon. Show that this angle A is 132. Okay, a pretty classic composite polygon question. The first one, let's go and call it number 1. Second one, number 2. So what I want to go and do is, I want to go and use the first formula to find the total of the interior angles divided by the number of angles to give me one angle. So let's go and get this angle in the first one, and then this angle in the second one, and at this point makes 360. So for the first hexagon, we can go and say, well, your number of sides, you've got 6 sides, so 6 take away 2, okay, times by 180, and that's going to give you a total of, well, that's going to be 4 times 180 is going to give you 720 degrees. So for a singular angle, okay, so for one angle, you can just go and do 720 and then divide this by, well, you've got, of course, in hexagon, you've got 1, 2, 3, 4, 5, 6 angles. Go and divide this by 6. If you do that, you're going to be getting 120 degrees. So this angle here is going to be 120 degrees. Now for the pentagon, similar thing. Okay, your formula up here, your number of sides take away 2. Of course, you've got 5 sides for shape 2. So you've got 5 take away 2. You're timesing this by 180. So that's going to be equal to, that's going to be 3 times 180, which is going to be equal to 540 degrees. You want to get one angle. Okay, so you can go and do 540 and then divide it by, there's 5 angles there. And to be honest, just because I've done this so many times, and it'll be similar with you guys, you'll recognize this kind of question, right? So 540 divided by 5 gives you 108 degrees for this angle up here. Okay, there we go. Now we know that the angles around a point are going to add up to 360. So to get angle A, we can go and say A is going to be equal to 360, then take away 120, take away 108, which indeed does give you 132 degrees as required. Okay, so there we go. I've shown that the angle A through all of my working here gives you 132. And this is my marks in the bank. Good. Now part B is this. It says, Imran thinks that another tile in the shape of a regular polygon will fit exactly into angle A. Is Imran correct? So he's sort of saying for part B, could you get another polygon of some number of sides kind of to fit into this here? Now, what I would go and do here is I would think, well, I'm going to zoom out a little bit. I know that this interior angle here, I'm going to go and draw it down here. So the interior angle here, okay, we've just found out is equal to 132 degrees. And we know that the interior angle plus the exterior angle is on a straight line, add up to 180. So this here must be equal to 48, because 48 add 132 gives you a straight line of 180. Now, if I put this into this formula, my exterior angle is going to be 48, okay? And I can then go and find the number of sides. And if n is a whole number, it will fit into the shape. If I get some decimal, then it's not going to work out, because you can't have a number of sides of like 3.5, for example. It's got to be a whole number. So using this formula, I can go and say that the exterior angle is 48, and that's going to be equal to 360 divided by the number of sides n. Now to go and find n, I can just go and switch these guys around and say that n is going to be equal to 360 divided by 48, and I can tell this is not going to be a whole number, but we'll work through it just to show the examiner exactly what's going on. If I go and divide these by, actually 12 is a common factor, so I can go and divide by 12 and go and divide by 12. Well, 360 divided by 12 is actually going to be equal to 30. So 30 over 48 divided by 12 is going to be equal to 4. I can go and half both of these, divide that by 2, and divide that by 2 again to give me 15 over 2. Now 15 over 2 is equal to 7.5. So my number of sides is 7.5. So is Imran correct? Definitely not, because you can't have a decimal number of sides. Yeah, it must be a whole number. So the answer is going to be no. You can't have 7.5 sides. Okay, and there we go. That's all you're working for this question up here, number 8. There we go. Okay. On to question number 9. We've got this. George is the manager of a shoe shop. He samples 50 of his customers. So these are going to add up to make a total of... Let's go and do it in red, actually. They're going to make a total of 50. He samples 50 customers, okay, and asks them about one style that they would buy next. The table shows the results. Okay, good. George buys 1,000 pairs. Okay. With the number of each style based on his survey results, how many pairs of sandals should he buy? So we're looking at sandals here. So what you want to go and do is find the proportion of the sandals that are bought in the survey, and then find that proportion out of 1,000. So you can see in the survey there was 8 over a total of 50. So that's the proportion that got sandals from the survey, and you want to find that proportion of the 1,000 that he's bought. Okay, and in maths, if you're finding of an amount, you are timesing your numbers together. So you're doing 8 over 50, and you are timesing by 1,000. And 1,000, I like to think of it as 1,000 over 1. They mean exactly the same thing. Now what you can go and do here is go and cancel out a 0 from up here and down here through cross cancellation, because you are multiplying fractions. So you've got 8 times 100 on the numerator, which will give you 800. And then you've got on the new denominator, you've got 5 times 1, which gives you 5. And here you could just use a bit of bus stop. You're saying how many 5s go into 800. 5 into 8 goes once, remainder 3. 5 into 30 goes 6 times. 5 into 0 goes 0 times. So it is equal to 160. So we should buy 160 pairs of sandals. Okay, and it also says, that's your answer, 160. There we go. It also says, write down any assumptions you make in his sample. Well, whenever you do a sample, okay, it's a classic response in the exam. You've got to make sure that the sample is representative. So you've only sampled 50 people, which isn't a huge amount. So you're assuming that 8 over 50 is representative of a bigger population. Okay, so that's the assumption you want to be making here. So the assumption, the sample is representative. That's a classic response. Okay, so it just comes with exam practice. You'll pick up on this kind of thing. And there we go. That is this answer. Let's put it in red. In fact, we'll leave it there. The sample is representative. There we go. Okay, good. Let's check the mark scheme. Sorry, I didn't even check. Question 8, question 9, 160, and part B, assume sample representative. Yeah, good. Okay, good. Absolutely fine. Question 10a, solve the inequality. So when you solve an inequality, you solve it the same way that you solve an equation. Just pretend that was an equal sign, but you manipulate it in the same way. So you want to go and begin here by adding on 2 to both sides of the equation, because then the 2's are going to cancel. They're opposite. So on the left-hand side, you've just got 3x left over, being greater than 10 plus 2, which gives you 12. So you've got 3 times something bigger than 12. You can now go and divide both sides by 3 and divide by 3. Of course, the 3's here are going to cancel. They are inverse. So you've got just x on the left-hand side being greater than 12 divided by 3, which is simply going to give you 4. So x must be greater than 4. And that is your answer for the first one. So x is greater than 4. 2 marks in the bank. Part B, solve this. Whenever you see an equation and you've got x on both sides, you want to get it on. You want to get the x onto one side and the numbers onto the other side. So I'm going to go and add this 4x onto both sides, because then of course they're going to cancel on the right hand side. So these guys here are going to cancel, and you've got 6x add 4x, which gives you 10x over here. You've still got the plus 2 on the left hand side being equal to, well, these guys have gone, you've just got a 5 left over. Now I'm going to go and take away this 2 from here and go and put it over here. So then you're going to go and get these cancelling, and you get 10x being equal to 5 take away 2, which is 3. So 10 times something gives you 3. You're going to go and divide both sides by 10 and divide by 10. You're going to get a decimal answer, absolutely fine, not an issue at all. So x is going to be equal to, you could actually just leave it as a fraction, but 3 divided by 10, of course, is just going to be equal to 0.3. And this is your answer. Okay, so you can write it how you want to. X is equal to 3/10, or you can write it as equal to 0.3. Okay, they're both going to be correct. Good. Question 11, vectors. Very nice. Vector A is 2, 1 and vector B is minus 2, 1. Just so we can kind of recap it, the way that a vector works, kind of like a coordinate. The top number is your horizontal direction. Okay, so if you go to the right, that's very, very messy. Apologies. Let's go and draw that again. A vector, if you go, the top number, sorry, is the horizontal direction. Right is positive, left is negative. The bottom number is up and down. Up is positive, down is negative. So on the grid below, draw a vector to represent 2 lots of vector A. So if we go and kind of look at this, it's just saying you've got 2 lots of the vector 2, 1. Okay, so 2 times 2 gives you 4. 2 times 1 gives you 2. So you've got to go and draw this on here. They're both positive, so it's going to be going on our grid. Anywhere on the grid you can go. We're going from any point, you're going 1, 2, 3, 4 across, up by 2, 1, and then 2. Okay, that is your vector. And probably you should label it on your diagram. You don't need to, I wouldn't have thought, but just 2, and then A. Of course, you can't write a vector in bold when you write it, so you write it underlined, okay? But it's just saying that you're going 4 across, 1, 2, 3, 4, up by 2, 1, 2. Part 2, you've got A, add B. You're going to go and add your 2 vectors together. So vector A, we can see is 2, 1. I'm going to add on vector B, which is negative 2, 1. Okay, well, 2 add minus 2 simply gives you 0. And then you've got 1 add 1 gives you 2. So actually, you're not going across, so you're not moving up horizontally at all. You're just going up by positive 2. So, one really important thing on the vector, I should have added in, right, arrows here. So I should have, that is a big, big important point here. You've got to show the direction of the vector. That is really, really important. Okay, so this way, the vector is, we started here and we're going to here. You've got to have the arrow showing the direction. Very important. Okay, this one, you're just moving in the positive direction up by 2. So let's go and draw this. So we're just going up by 2. There is 0 horizontal movement because the horizontal component is 0. And again, the direction here, you've got to show with an arrow, bam, 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 there we go. You're going from here up to here. That's really important. Okay, and I'm just going to go and label the vector on there as vector A plus B. Okay, good. So there we go. Good, that should be 2 marks in the bank. Now, Emma says if she draws vector A and vector B, they will be the same. So you can see vector A and vector B is here. Explain why this is incorrect. They're not the same because the horizontal component is opposite, so the direction will be different. So you can just go and say for 11B, they're going to be in different directions. If you were to go and draw these out, okay, I will show you. Actually, I'm not going to show you, but because this is positive and this is negative, the directions are going to be different. So that's your answer for this part. Simply, the directions will be different. Okay, good. Part C, you've got vector C is minus 12, 0. Find the value of k such that some multiple times vector A take away vector B equals to vector C. So let's just go and kind of put this all in here. So you've got some number k. K is not a vector because it's not bold. It's just, you call it a scalar multiple. It's just going to be a number. And in a bracket, well, vector A, let's kind of zoom out so we can see what is going on again. Vector A we know is 2, 1. So you've got vector 2, 1. You're taking away vector B, which is negative 2 and then 1. Okay, and that's equal to vector C, which we've just seen is minus 12 and then 0. And now we're just really manipulating our vectors here. So you've got some number k, and you're going to be doing, well, 2, take away negative 2, just means 2 plus 2, so it's going to be 4 on the top. And then, of course, 1 take away 1 gives you 0, so 4, 0 is equal to minus 12 and then 0. So what number times 4 gives you minus 12, and what times 0 gives you equal to 0? It's going to be equal to, negative 3. So when k is equal to minus 3, okay, well, minus 3 times 4 gives you minus 12, and minus 3 times 0 gives you 0. So the value of k is going to be equal to negative 3, and that is your answer, okay, negative 3. Okay, just so you'll know, because minus 3 times 4 gives you minus 12, and then minus 3 times 0 gives you 0, okay, and that's your answer. Perfect. On to question number 12. We've got this, another wordy one. Helen delivers parcels. Okay, right. On Tuesday, Helen delivered 20% more parcels than on Monday. Okay. On Wednesday, Helen delivered 50% fewer parcels than on Tuesday. Very nice. And on Wednesday, Helen delivered a total of 72 parcels. Calculate the number of parcels that Helen delivered on Monday. Now, because we don't know how many parcels she delivered on Monday, I'm going to go and say X is equal to the number of parcels delivered on Monday. Okay. Now that's important. Now on Tuesday, okay, so my handwriting is not too good, but hopefully you can read that. On Tuesday, okay, she delivered 20% more. Now 20% more, if I do it over here, is you always start at 100%, and if you're doing 20% more, you're adding on 20%. So you're increasing by 120% as a percentage multiplier into a decimal form. So divide that by 100, you're going to be timesing by 1.2. So on Tuesday, you had 20% more than Monday. So on Monday there was X, and 20% more, you're going to be timesing this number by 1.2. Okay, this is a 20% increase from Monday. And then on Wednesday, over here, on Wednesday, Helen delivered 50% fewer parcels than on Tuesday. Okay, nice. So now 50% fewer, again, you always start at 100%. If it's 50% fewer, you are decreasing by 50%, which is going to give you 50%. So as a percentage multiplier, you're going to be timesing by, well, 50 divided by 100 is going to be 0.5. And on Wednesday, Helen delivered 50% fewer parcels than Tuesday. So 50% fewer than this number. So you've got to go and do 0.5 is a 50% reduction of the whole of Tuesday, which is x times 1.2. Okay? And you know that on Wednesday, she delivered 72 parcels. So you can go and put this here equal to 72. So you can go and say that that's going to be equal to 72. And this is an equation that you can now go and solve. So you've got 0.5 timesing by all of this here. To get rid of that 0.5, you can go and divide both sides by 0.5. Okay, so now I'm going to go and divide both sides by 0.5 to cancel out this one here. So I can go and say that x times 1.2 is equal to, now if you divide 72 by half, you actually double it. Because if you think about it, 0.5 goes into 72 144 times. So some number times 1.2 gives you 144. I'm now going to go and divide both sides by 1.2. Therefore, x is going to be equal to 144 divided by 1.2. Actually, I'm going to go and write it as a fraction because it looks a little bit nicer. Now, the thing is, right, if you're dividing by decimal, not particularly easy. Let's just go and upscale this now by timesing top one by 10, times that by 10. So it's going to be equal to 1440 divided by 12. So we're saying, bus stop, how many 12s go into 1440? Now 12 into 1, of course, doesn't go. So you've got to go and carry that 1. 12 into 14 goes once, remainder 2. 12 into 24 goes 2 times, exactly. 12 into 0 goes 0 times. So it's going to be equal to 120 were delivered on Monday. Good, because we found x. Yeah, sorry, x is equal to 120, and x is the number of parcels on Monday. So hopefully, I haven't misunderstood something there. Question 12, it is 120. So this is your answer. Okay, good. 5 marks in the bank. Okay. Question 13a is write 7/9 as a recurring decimal. This is actually just bus stop. You are saying, because this means by definition 7 divided by 9, you're saying how many 9s go into 7. Now, it's not going to work out because 9 is bigger than 7, so go and put a point here and add in a few zeros, and let's go and do a bit of bus stop. I recommend that you might want to write down your 9 times table, just it will make it a little bit easier to kind of see what's going on in a second. So 9, 8, 27, 36, 45, 54, sorry, it's a bit messy, 63, 72, 81. Okay, fine. So how many 9s go into 7? Of course, it isn't, so 0. You're going to put up the points here, and you're going to go and carry that 7. Now 9 into 70 goes 1, 2, 3, 4, 5, 6, 7 times before you go over. So it's going to be 7 gets you to 63. 63 to 70, you've got a remainder of 7. And you can see it's going to be the same thing going on now. 9 to 70 again goes 1, 2, 3, 4, 5, 6, 7. Remainder 7, so you've got 7, remainder 7, and the pattern continues 7, remainder 7, 7, remainder 7. So you can see, as a decimal, it's going to be 0.7 recurring. Okay, and that is your answer for part A. Part B, lovely question. Okay, it's just recognizing that, right, Sally divided a 2-digit number by another 2-digit number, and her answer is this, 3.18181818. Find the 2 numbers that Sally could have used. Now, this is just classic exam practice. It's just thinking, well, you're given a recurring decimal, you want to write it into a fractional format, so something A over B. And there's a process that we can always do for this. So let's go and call this number x being equal to 3.181818. Now, if I times this x by 100 and go and get 100x, okay, 100 times by 3.181818 is going to give me 318 points, and then 1818, and then 18. Okay, if I times that by 10, these numbers here wouldn't match up. And this is really important that they do match up, because now we're going to go and subtract these two here. We're going to go and do a subtraction. So we're going to be doing 100x take away 1x, which gives you 99x being equal to, you've then got 318 take away 3, which is going to be equal to 315. And really importantly, really importantly, these parts here, they're all just going to cancel out, okay? Because if you take these away, they're all just going to become 0. 1 take away 1 is 0, 8 take away 8 is 0, so this just eliminates, which is really useful. So this is just converting a recurring decimal into a fraction. So if we can do this, it's just spotting the question. Now to go and get x here, you've got to go and divide by 99. So x is going to be equal to 315 over 99. But the question is saying it's got to be a 2-digit number divided by a 2-digit number, and this is 3 digits, so you've got to kind of simplify here. Now, I recognise that 315, because 3 add 1 add 5 gives you 9, which is a multiple of 3. You can divide it by 3, and you can also divide 99 by 3. So if you do 315 divided by 3, so quick bit of bus stop, 3 into 315, it's going to be 1. It doesn't work, so carry the 1, it's going to be 5. So it's going to be equal to 105 over 33. Now, unfortunately, this is still not a 2-digit number, so let's go and divide it by, let's say, 3 again, divided by 3, divided by 3. 105 divided by 3 is going to give you, let's do a bit of bus stop, so 3's in 2. 105 is going to be, not going to work, carry the 1, it's going to be 3, remainder 1. 3 into 15 goes 5, so 35 over 11. And this is good, because you've got a 2-digit number, 35, by another 2-digit number, 11. So this is going to work. You can do 35 and 11. You could also do something else. If you wanted to, you could go and maybe times this by 2 and times that by 2 to give you 70 over 22. So you could also go and have, or you could have 70 and 22 will both also work, okay? Lovely question. It looks really complicated. If you have been taught, okay, or if you don't, you can watch my videos on this, converting from a recurring decimal to a fraction. It's just spotting the exam question, okay, and the question becomes relatively okay. Question 14, again, just by looking, it's just exam practice. I'm looking at this, and I'm not even reading the question, and the more papers you do, you'll just spot what they're asking for. This is a product rule for counting question, because it's about combinations. John has got 8 different shirts, 6 different hats, and 4 different scarves. On Monday, he picks a shirt, a hat, and a scarf. Okay. Show that there's 192 different combinations. So it's just saying, right, for shirts, you've got this, you've got 8 combinations. For hats, it's going to call that H. You've got 6, and then for scarves, it's going to call that SC. Otherwise, it will get confusing with S. You've got 4. Now, to find how many different combinations, outfits, you just simply times those together, okay? So if you go and do 8 times 6, times it by 4, you do get, 8 times 6 times 4 gives you 192. That is simply going to be it, okay? There's 192 different ways you could get dressed with this, this, and this. Part B, what's this saying? John thinks if he picks just 2 of the 3 items, there will be more than 192 combinations. Is he correct? Well, if you pick just 2 of these combinations, you could choose, a scarf and a hat. Okay, that's 2 combinations. Or you could go for, a shirt and a hat. You could go for a shirt and a scarf. Or you could go for a hat and a scarf. And that's all the sort of different 2 items that you could go for. You can't go and write again HS, for example, because the order doesn't matter. If you go for a shirt and a hat, or a hat and a shirt, it's going to be the same thing. Now, if we look at the first one, you've got a shirt and a hat, or you've got 8 different shirts and 6 different hats. So to find different combinations that you could get there, you can just go and say you've got 8, and you can times that by the number of hats, which is going to be 6. 8 times 6 is equal to 48, so that's going to be that one. There we go, 48. So there are 48 different combinations you can make from a scarf and a hat. With a shirt and a scarf, it's going to be, a shirt is 8 and a scarf is 4. So it's going to be 8 times 4, which is equal to 32. And then you've got a hat and a scarf. Hat is 6, scarf is 4, so you can go and do 6 times that by 4, which equals to 32, and if you add these together, it's going to be less than 192, just through inspecting it, because 8 add 2 add 2 gives you 12, and then 4 add 3 add 3 is going to give you 10, 11, sorry, 4 add 3 is 7, add that 1, 10, oh, I've made a mistake here, looking at the marks, 14b, shirt scarf, 18 4 32. Sorry, pretty silly mistake. Okay, that should be 24, shouldn't it? That's not good. That should be 24. Apologies, guys. That should be equal to 24 over there. 8 add 2 is 10, add the 4, 14, and then 4 add 3, 7, 9, 10, 104. Okay, so actually, is he correct? No, because you can make 104 different combinations, so you can go and say something like this, that you can say 104 is less than 192, so he is incorrect. Okay, good, and that gives you the 3 marks for this question. Good. Question 15 is simplifying surds. You've got simplify fully, root 50, add root 2. Now, this is saying root 50, you can write it as 2 numbers times together, where one number you can root it. So here you can go and do 25, and you can times it by 2. So that is root 50. And then here you can break it down. You can go and say, well, you got root 25, and you're timesing this by root 2. Root 25 is 5. 5 times root 2 is just 5 root 2. So root 50 is equal to 5 root 2, and you're adding on root 2, which is that. And because now you've got a like term, you've got 5 root 2, add 1 root 2, it's simply going to be equal to 6 root 2. Okay, so that is your answer for this one over here, 6 and then root 2. Because from your laws of surds, root a times b is the same thing as root a times root b. Okay, so that's one of your laws of surds. And there we go, 6 root 2. This one here, you want to simplify this. If you have a surd on the bottom of a fraction, you want to rationalize it. And you do that by multiplying through by the bottom number, which is root 6 over root 6, because effectively this is just the same thing as timesing through by 1, because root 6 divided by root 6 is the same thing as 1. Now, if you do the top, 10 times root 6 is just going to be 10 root 6 on the top, and then you've got root 6 times by root 6, which is going to be equal to root 36. So that's going to be equal to 10 root 6 over root 36 is equal to 6. And we can do a bit more simplifying here, because 10 and 6 you can go and divide by 2 and divide by 2. So this is going to be equal to 5 root 6 over 3, and this is your answer, 5 root 6 over 3. Hopefully no mistakes there. 6 root 2, 5 root 6 over 3, perfect. Okay, and there we go. Question B on this one. There are 2 errors in Sam's method for finding the value of 64 to the power of negative 2/3 shown below. Okay, so this is his method. Find the cube root of 64 and then multiply by 2. That's going to be wrong. I'll show you why in a second. And the cube root of 64 is 4, and the 4 times 2, right? Let's just, when you get this kind of question, describe these errors and then give the correct value. Just go through it how you would do it, the correct way, and then you're going to see what the errors are going to be. So if we go and look at this, we've got 64 to the power of minus 2 over 3. Now, whenever you see a negative power, you think reciprocal. So you go 1 over your number, which is 64. You then put it to the power, which is 2 over 3. Okay, so negative power, you always take the reciprocal, so 1 over. So the negative power does not make the answer negative. This bit is wrong. It means reciprocal. So first of all, the negative power means take the reciprocal, not make the answer negative. That's the first thing. Okay, good. Let's just keep working through the question. Now, here we've got equal to 1 over fractional power. So if you've got a fractional power, you've got to go and root your number. So you root it. The root that you take is the denominator of the fraction. So you're taking the cube root of 64, and then you put that all to the numerator of the fraction. So you put it to the power of 2. There we go. Okay, and that's going to give you 1 over the cube root of 64, which is this part here, does indeed give you 4. So that is correct. Okay, so you've got 1 over 4, but then you're doing 1 over 4 squared. Okay, so you don't do 4 times 2, you do 4 squared. That's the second mistake. Okay, so it's not 4 times 2, you do 4 to the power of 2. I was just going to write 4 squared. Okay. That's the second mistake. And now simply, if we look at the fraction here, you've got 1 over 4 times 4, which is going to give you 1 over 16. That's your answer. So the correct value should be 1 over 16 for 3 marks. Let's check the mark scheme. Correct, 1 over 16. Good. Question 16a, circle theorem. So you've got A, B, C, D are points on the circumference of a circle. So you've got a cyclic quadrilateral here, A, B, C, D. Angle BAD, where the middle one is the angle you're looking for, as you can see on the diagram. So you've got BAD is 52. Work out the value of x, which is here. Give a reason for your answer. Now x is going to be equal to 104, and the reason is angle at the center is double the angle at the circumference. It's one of your circle theorems. So you can say angle at the center is double the angle at the circumference. Good, there we go. That's the first one. That's one of your basic circle theorems, or like one of the kind of standard ones. And then part B, work out the angle y. So what I'm seeing here is you've got 52 here and you've got y here. You've got if I go and highlight this, you've got this over here, okay, which is a cyclic quadrilateral. And we know that opposite angles in a cyclic quadrilateral, they add up to 180. So it's going to be 180, take away 52, which is going to give you 128. So 128 degrees. So angle y is 128. And the reason is, opposite angles in a cyclic quadrilateral add up to 180. There you go, that's your answer. Okay, or you can say that they are supplementary. They mean the same thing. Let's check the mark scheme. 104, 128, perfect. Actually, this one's quite a simple circle theorem question. Nothing too crazy going on there. Just applying 2 of your rules. Okay, yep, good. Question 17a, simplify this. Okay, whenever you get this is a algebraic fraction. You want to go and factorize the numerator and the denominator. Now, this part up here, the top one, this is the difference of 2 squares. So it's going to go into the form. You've got a square number, take away another square number. When you have this, it goes into a double bracket where you've got a plus b and then a minus b. So this is going to go into the top part, a pair of double brackets, the difference of 2 squares. Now, what times what gives you x squared? Well, x is going to go here, and then what times what gives you the square? So 16, it's going to be 4, and then you just go and put plus and minus in here. So you factorize the top part, and then you're putting that over the denominator of the bottom part, and this one here is actually just a simple quadratic because you've just got x squared. So this is going to go into a pair of double brackets where you need numbers that multiply to give you the last part, which is -4, and that add to give you the middle number, which is -3. These numbers are going to be -4 and +1. Let's check it. -4 times 1 is -4, and -4 add 1 gives you -3. So it's simply going to be x -4 and then x plus 1. Okay, so up here, x -4 and x plus 1, and it's always with these questions, right, you're going to get at least one bracket that's going to cancel. You can see you've got an x minus 4 and an x minus 4. Because you're timesing, you can simply go and cross cancel. These are going to go, and you've just got x plus 4 on the top over x plus 1 on the bottom. So it's simply going to be x plus 4 over, and then x plus 1. There we go. That's your answer. Okay, x plus 4 over x plus 1. Question 17. Good. 4 marks in the bank. B, you've got this here. You've got a triple bracket is identical to this here, where you want to find the values of A and B. Now, there are a few tricks that you could here to make it a little bit easier for yourself. Like B is just going to be the number parts times together. But actually, what you could just go and do is expand all of the brackets, and then you're going to go and see what the coefficients A and B are going to be. So actually, I'm just going to go and do that. I'm going to begin by expanding the first two brackets. Okay, so I'm going to be going and expanding x plus 3 with x take away 4. So just our FOIL method. Let's go through this. So it's going to be equal to x times x, which is x squared. X times by minus 4, so minus 4x. And then 3 by x, which is plus 3x. And then 3 by minus 4 gives you minus 12. Of course, this part here you can simplify. Okay, so it's going to give you x squared. And then minus 4x add 3x will give you negative 1x, so just negative x. And you've got that minus 12, which is there. So the first two brackets, they give you x squared minus x, and then take away 12. And you're timesing this still now by the third bracket, which is x plus 5. And we're just expanding, kind of like with the first method, all of your terms like this. Okay, so then you've got, and also the minus 12 by the 5 and the plus 5. Okay. Now, just go through this really carefully and you should be okay. X squared by x is going to give you, in fact, that's really messy. I'm not very happy with how I've written that. So it's going to do x times by 5. That's also not very neat. I'm just saying, sorry, that you're timesing the minus 12 by the x and the minus 12 by the plus 5. Now, x squared times by x is going to give you x cubed. You've then got x squared by plus 5 is going to be positive 5x squared. You then got negative x by positive x, which is going to be minus x squared. You've then got negative x by plus 5, which is going to be minus 5x. You've then got negative 12 times by x, which is going to be minus 12, and then x. And then you've got negative 12 times by plus 5, which is equal to negative 60. And we're looking at like terms here. So you've got a 5x squared and a minus x squared, and you've got a negative 5x and a negative 12x. Okay, so we've got x cubed. 5x squared take away x squared is equal to positive 4x squared. Minus 5 take away 12 is minus 17, so minus 17, and then x, and you've got that take away 60. Now, if you go and compare this with what you've got in the question up, what's happened there? What has happened there? Okay, so sorry, with this up here, you've got x cubed. I'm just going to write it in red. You've got the x cubed part plus some number a x squared, and it tells you you've got 17x, which you can see you've already got, plus some number b. So you can go and clearly see now that a must be equal to 4 and that b is equal to negative 60. Okay, so a is equal to 4 and b is equal to minus 60. Okay, you can do this in quicker ways, but actually it's probably just easier just to expand the whole thing, because then you can kind of check that you get the minus 17, and we're going to be correct. If I check the mark scheme, we are indeed correct. 4 and negative 60. Good. So that was question 17b. Question 18. Question 18, we've got this. In a group of 120 adults, 85 watch football, 78 play sport, and 20 do neither. So I'm recognizing this is going to be a Venn diagram question, okay? And it says find the probability that an adult chosen at random from these who watch football. Okay, right, let's highlight some words here. So in a group of 120 adults, you've got a total of 120, 85 watch football, 78 play a sport, and 28 do neither. Okay, find the probability that the adult chosen from random watch football and does not play a sport. A lot going on here. Let's just draw out a Venn diagram. Okay, so let's go do this down here. Bam, 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 and then bam. Okay, so I don't know why I drew it so big. Let's make it a little bit smaller. There we go. There we go. There we go. There we go. Now, Venn diagram, let's go and draw our circles in. So you're going to have over here and then over here. Now, you know that the total is 120. You know that we've got, I'm going to watching football, I'm just going to go and put is F for football and then S for playing a sport. So you've got football as the first circle and then sport as the second circle. And 20 do neither. So you know straight away that 20 is going to be in the outside. Now, 85 watch football. That means in the whole of this circle here, okay, you've got a total of 85 people, 78 play sport. So in the whole of this circle here, 78 play sport. What you don't know is those that do both football and play a sport. Okay, so I'm actually going to go and call this the letter X. So X is going to be, this is going to be X is both, plays both, watches football, and plays a sport. Okay, this is what you don't know. Now, the whole of this one here is worth 85. So just this part here, okay, just this part must be 85, take away the X. So in this spot here, it's going to be 85, take away X. And then 78 play sport. So the whole of this circle is worth 78 here, which means that just this part, okay, here, not the middle part, must be 78, take away this X. So that must be 78, take away X. And now we can form an equation to go and find X, and this will be useful for later on. So let's now go and add all of these up, and it's going to be equal to 120. So if we go and do 85, take away X, so that's just football, plus X, which is both, plus just sport, which is 78, take away X, plus the neither, 20, that must equal a total of 120. Now this is collecting like terms. You've got a minus X, a plus X, another minus X, and you've also got a 85, you've got a plus 78, and you've got a plus 20. Now, these X's are going to cancel, minus X plus X, so you've just got a singular minus X left over. So you've got minus X there. You've got 85, add 78, add 20, which is going to give you 9,883. Let's just double check that. 78, add 20, add 80, 85 is 183. So minus X, add 183 is equal to the right side 120. Now, you can go into here that X is going to be equal to 183, take away 120. Okay, I've just kind of rearranged it twice, but that's what it's going to be equal to, and that's going to be equal to 63. So now, in your Venn diagram, it's going to zoom in a little bit over here. Now it's going to zoom in a little bit so you can kind of see it more clearly. We now know that, I should draw it a little bit bigger actually, but this is going to be fine. We know that because X is equal to 63, let's go and do this now, go and highlight that, X is 63, the middle part is 63, this is 85, take away 63, okay, which is going to give you 7 to 70, 17, add to 5, 22. So this, well, let's go and write to 85, take away 63, which is X, is going to give you 2 and then 2. So this must be worth now 22. This part here, 78, take away X, let's go and do it here, 78, take away X, which is 63, is going to give you a total of, take them away, 5 and 1, 15, and there we go. And if you check, if you could 22, add 63, add 15, add 20, you do indeed get a total of 120, which is good. Now the question is saying find the probability, so find the probability, capital P, that the adult chosen at random, from those who watch football, okay, does not play a sport. So from those, so does not play, sorry, probability that they, let's make it clear, probability that they do not play a sport, given, this means like given that you know they watch football. Okay, so given you know that they watch football, it's going to be out of a total of 22, add 63, okay, which is going to be equal to 85. It's going to be out of your total, okay, which is the 22 add 63. And the probability that they do not play sport, well, it must be, if it's in the middle, that would include people that play sport, so it must be the 22, because these just watch football. Sorry, the probability that they do not sport, given that they watch football, make sure we're getting this right. So given that they watch football, probability that they do not, it must be 22. So 22 out of 85, because you're looking, this number here is not playing a sport. Okay, this is just watching football. And the total watch football is the whole thing here, which is these added together. This is actually worded quite difficultly. Okay, so you might have to kind of think about that a little bit more. But let's check the mark scheme. Hopefully I haven't made any blunders there. It is 22 out of 85. Okay, so this is indeed your answer. So let's zoom out and put it down here. So 22 over 85. Okay, there we go. Now on to question 19a. It is sketch the graph of this. Show the coordinates of any turning points. So this is in completed square form, and you've got to be able to recognize that it's a quadratic, because you've got it's going to give you x squared up here. So it's going to be, and it's positive, so it's going to be something in this format here. And basically, right, the coordinate of the turning point is the opposite sign of the bit in the bracket, so +2, and you keep this one the same. So the turning point is going to be 2 and then -3. So if we go and plot that on here, it's just a sketch, so somewhere going to be down here. That is the bottom, okay, that 2 minus 3 is the bottom of the quadratic. Also, you can work out where it crosses the y-axis, okay, because if you go and put x equal to 0 into the equation, you're going to be getting y is equal to x is 0, so 0 take away 2 squared take away 3, so y is going to be equal to -2 squared take away 3, y is equal to -2 squared is +4 take away 3 is going to give you 1. So when x is 0, the y value is 1, so x is 0, y is 1, it's going to be up here somewhere, okay. So it's going to be a quadratic that something like this, it goes through here at the y-intercept, the minimum point or the turning point is down there and then up here. So this here is what you call the turning point. You just change the sign of this here to give you +2 and you keep this one as -3. And this is just a sketch of the graph of the quadratic. 3 marks. Part B. The sketch shows part of the graph which has the equation y equals x squared plus bx plus c, so it's a quadratic, as you can see. Find the values of a, b, and c. Now this here, you know when x is 0, the y value is 12. So this is just saying when x is equal to 0, y is 12. Let's make a note of this. When x is equal to 0, y equals to 12. Let's go and put this into this, and we can get the c value. So putting it into our equation, so you've got y is 12, so you've got 12 is equal to a times x squared, so a times 0 squared when x is 0, plus b times by x is 0, so just 0 again, plus c. So it's going to be 12 is equal to c, so that's your c value. Okay, the first one, good. Now for these ones here, you've got, now when y is 0, because it's on the x-axis, you've got x being -3 and x being -1. So if we look at the first, well, if we look at -3 first of all, you can go and say when x is equal to -3, the y coordinate is 0, okay, because x is -3, y is 0, and you can go and put it into your equation up here, and you now know that c equals to 12. So you can go and say that y which is 0, is equal to ax squared. So it's going to be a, x is negative 3. You're squaring it, plus bx, so plus b times by x, which again is negative 3. And you know that plus c is 12, so plus 12. So you're going to get an equation here. So 0 is equal to negative 3 squared is plus 9, so plus 9a, and you've got minus 3b, and you've got plus 12. Okay, there we go. Now actually I'm going to recognise here that when we do the same thing for minus 1, you're going to get a pair of simultaneous equations. I'm going to go and get this 12 onto the other side by taking it away. And if we do that, you're going to get 9a, take away 3b is equal to minus 12. I'm going to go and call this equation 1. Okay. Let's do a similar thing now with x being equal to negative 1, because we know now when x is equal to, minus 1, the y value again is going to be equal to 0. And putting these values of x minus 1, y equals 0 into the equation up here, you're going to be getting y, which is 0, is equal to a by x is minus 1, so minus 1 squared, plus b times by x, which is negative 1, and c is 12. So it's going to be, scroll down a bit, it's going to be 0 equals to negative 1 squared is 1, so 1a minus b plus 12. Again, it's going to put the 12 on the other side, so it's going to be a take away b equals to minus 12. And this now is going to be equation 2. So let's go and kind of zoom out a little bit and get it all onto the screen. There we go. So let's go and kind of write this now up here somewhere, okay, and solve these two simultaneous equations to get a and b. So if we go and do this, we know that equation 1 is 9a, take away 3b is equal to negative 12. You know that equation 2 is a take away b equals to minus 12. Now, you want to get either the a coefficients or the b coefficients to be the same. I'm going to times equation 2 by 3, okay, times this one by 3. So then we're going to be getting, in fact, I'm going to rub this out. There we go. So I'm just saying now that 3 times equation 2, so 3 times this, you're going to be getting 3a, and then 3 times by minus b is going to be minus 3b, being equal to 3 times by minus 12 is going to give you negative 36. This is good because I've now got the b coefficients are both minus 3, and to get rid of these now, I can go and do equation 1, take away equation, this one here, so I can go and do equation 1, take away equation 2, which I've times by 3. If I do this, I'm going to be getting 9a take away 3a, which is equal to 3a, and then a minus 3 take away a negative 3 does in fact cancel to give you 0, and that's going to be equal to negative 12 take away negative 36, so that's minus 12 add 36, which is going to be equal to positive 24. Okay, so hopefully my a value is going to be equal to 8. Let's double check, 19b. Oh, I think I made a bit of a mistake here. So what's happened here? So we've got, I think it equals minus 12, that's fine. And we've also got 3a plus 12. What's happened here? Ooh, you know what, guys? Right, I think, let's go back a little bit. I can see I've made a mistake on the mark scheme. Right, what I can recognise on this equation here, apologies guys, right, equation number 1, I'm actually going to go and divide everything by 3 because this will simplify it a little bit easier because they're all factors of 3 here. So we're going to get 3a, take away b, equals to negative 4. So actually I'm going to go and call equation 1, this one down here. Bam, there we go. So up here now, equation 1, I must have made a mistake somewhere. Equation 1 is 3a. 3a take away b is going to give me minus 4. And equation 2, I can keep it the same as just A take away B equals to minus 12. And actually now it's a little bit easier to work with. The numbers are smaller. Again, I can go and do equation 1 take away equation 2. So 1 take away 2, because 3A take away A is going to give me 2A. They're cancel because negative 1B take away negative 1B gives you 0, and then you've got that being equal to negative 4 take away negative 12. It's going to give you positive 8, so A should be equal to 4, which is correct. Okay, I'm not quite sure what I did the first time there, but A is 4. That is good. Now to go and get the value of B, I can go and put A equals 4 into either of my equations. So let's go and put A equals to 4. Let's go and put it into equation number 1. So it's going to be 3 times A, which is 4. Take away B equals to minus 4. So 3 times 4 is 12. Take away B gives you minus 4. So minus B is going to be equal to minus 4 take away 12, which is minus 16. Divide both sides by negative 1. B must be equal to 16. And that's the value of B. So B is 16. Okay, good. There we go. Apologies, guys. I messed up a little bit on that one there, but all good. That's the reality. Sometimes you go through it and you make a mistake, but there we go. Hopefully that was clear though. In the end, question 20 looks like a trigonometry and Pythagoras question. It says the diagram shows the land in the shape of a quadrilateral, A, B, C, and D. AB is 3, AD is 5, CD is 12, as you can see, and angle BAC here is equal to 30. The land is sold for 10 million per square kilometre. Calculate the cost of the land. Now, because it tells you it's 10 million per square kilometre, it's an area question. You want to find the area of both of this triangle, and then you can work out the cost of the total of the land. So let's go and consider, first of all, the area of triangle 1, because that will be a little bit simpler to do. So if we look at triangle 1, the area is going to simply be for triangle 1. Let's go and undo that, sorry. Right, the area is a triangle. It's a right angle triangle. It's going to be half times the base times by the height. It's going to be equal to half times the base, which is 12, times the height, which is equal to 5. That's going to give you 12 times 5 is 60. Half of it is equal to 30. So that's the area of triangle 1. Now for triangle ABC, it's a non-right angle triangle. I'm recognizing that we can use the half AB sine C to get the area of this one. So actually, if I go and get the length of this side here, I'm going to be good to go. So what I'm going to go and do is look at this triangle here, triangle ADC. Let's go make a little sketch of it. I'm going to go and draw it this way up. So we've got bam, bam, bam. Okay, this here is a right angle, and you know you've got this here is equal to 5, and this is 12. Now from Pythagoras, we can get this side here, so side C. A and B are your two shorter sides, so side A and side B. And Pythagoras' theorem states that the sum of the two shorter sides squared is equal to the longest side squared, C squared. So it's going to be 5 squared, add B squared, 12 squared is equal to C squared. 5 squared is 25, add 144 is equal to C squared. So you've got 169 is equal to C squared. So C is going to be equal to the square root of 169, which equals to 13. So you know that C is equal to 13. So A to C, this here is a length now of 13. Now we can go and use the sine rule for a triangle, area of a triangle using sine. We've got this triangle. Let's go and draw it in black again. So triangle ABC. Bam, bam, bam. Okay, so I've just drawn this triangle ABC down here. You know that this here is equal to 30 degrees. You know that AB, this bit here, is equal to 3. And you also know that AC is equal to 13. Now, if you're given an angle with its two adjacent sides next to it, you can use the formula to get area, which is area of a non-right angle triangle is half times A times B times sine of the angle C, where C is the big angle and A and B are your two shorter sides next to the angle. Okay, so the area here is going to be half times the value of A, which is 3, times by B, which is 13, times by sine of the angle C, 30. Now, sine 30 is an exact trig value that if you put this into your calculator, which you can't do, but if you did do it, you would see it equals to 1 over 2. So you need to know this exact trig value, okay? So now you can go and kind of clear this up a little bit. You can go and say that's equal to half times by 3 times by 13, which is equal to 3 by 13 is 39, and sine 30 is equal to 1 over 2. So you've got a half times a half, which is a quarter. So you've got 1 quarter times 39, which is equal to 39 over 4. So 39 over 4 is the area of triangle 2. So if I just kind of, there we go, put this up here. So for triangle 2, the area is this. Now 39 divided by 4, I want to go and see what that is as a decimal. So how many 4s go into 39. 4 into 3 doesn't go, carry that 3, put some zeros here. 4 into 39 is going to go 9 times remainder 1. 4 into 10 goes twice, remainder 2. 4 into 20 goes 5 times. So this is actually equal to 9.25. So the area of the first triangle was equal to, where's it gone? Was equal to 30. And the area of the second triangle, triangle 2, is 9.25. So we can say that the total area is equal to 30 add 9.25, which gives you 39.25. And it's going to be kilometers squared. Now you know that for 1 kilometre squared, it's 10 million pounds. You've got 39.25 of them. You can go and do your 10 million. So you can go and do your 10 million and times it by 39.25, which will give you 392.5 million. Okay, million per square kilometre, per kilometre squared. And this should be your answer. 39. Oh, I made a slight mistake. 3, not, what's happened there? Oh, what have I done? It's probably something really silly. 39 divided by 4. Sorry, guys. Right, it's a really silly mistake. This bit here should have been 9.7. I'm going through too quickly. 9.75. That should have been that. So that should be. Let's go and quickly make a change there. That should be a 7. 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 So that's going to check. Sorry, guys. That should be a 9.75. Let's do it in red as well. Keep it in red. There we go. Keep it in red. Keep it in red. So the final answer is going to be 397.5. Sorry, just a really silly mistake there. Okay, but there we go. That is your answer. Highlighter. There we go. So this is your answer. So 397.5 million. 7 marks in the bank. Okay. Good. Question 21, the last question. You've got n is an integer, a whole number. Explain why m2n plus 1 is an odd number. Now, if you just look at the 2n part over here, if we just look at 2n, let's do it over here actually. So 2n just produces the 2 times table. So like when n is equal to 1, n is equal to 2, and n is equal to 3. Well, when n is equal to 1, 2 times 1 gives you 2. When n is equal to 2, 2 times 2 gives you 4. So 2, 4. When n is equal to 3, 2 times 3 gives you 6. So 2n are the even numbers. Okay, it's your 2 times table. If you add 1 to an even number, it's got to be odd. So you just say this, 2n are your even numbers, and 1 add an even number must be odd. Okay, good. Part B, it says prove that the difference, which means subtraction, between the squares of consecutive So one after the other, odd numbers is a multiple of 8. So if you go and look at one odd number, okay, like 2n plus 1 is an odd number, okay, because let's just say if n was equal to 2, 2 times 2 is 4 and 1 is 5, well, the consecutive odd number, the one after must be 2n plus 3, okay? These are going to be consecutive one after the other. Now, if we go and take the squares of these numbers, so you go and take the square of both of these and do the difference, we're going to see how it becomes a multiple of 8. So if you go and take 2n plus 3 and we square it, that's going to be equal to 2n plus 3 times by 2n plus 3. So it's expanding a pair of brackets. There we go. So it's going to give you 4n squared, 2n by 3 is going to give you plus 6n, 3 by 2n, another plus 6n, and then 3 by 3 gives you plus 9. And of course that simplifies down to give you 4n squared plus 12n and then plus 9. If we go and square this one, so the odd number before, so 2n plus 1, and we square it, similar thing again, we get 2n plus 1, we're timesing it by 2n plus 1, expanding out the brackets, you're going to be getting, I'm going to go and do it in one go this time, it's going to give you 4n squared, 2n, but you got it twice, so it's going to be plus 4n, and 1 times 1 gives you plus 1. Okay, now the difference between this one and this one, if we go and sort of take these away now, okay, well, 4n squared take away 4n squared, these, let's write it over here actually, because it's going to be a bit more neater, so let's go and write them over here again. So you've got 4n squared plus 4n squared plus 12n plus 9 over here, and you've got 4n squared plus 4n and then plus 1 over here. And if you take these away, well, these here are going to cancel out because they're the same thing. You get 12n take away 4n, which is going to give you plus 8n, and then you get 9 take away 1, which is going to give you plus 8. And then when you get to 8n plus 8, you can factorize out an 8, okay, to give you 8 bracket n plus 1. And no matter what this is equal to, okay, this must be a whole number, because if n is an integer, which is a whole number, if this was equal to 3, 8 times 3 would be 24, a multiple of 8. If n was equal to 7, 8 times 7 would give you 56, which is a multiple of 8. So you can go and say that 8 times by any integer will be a multiple of 8. And this is your final answer for the 5 marks, okay, which I can't see on my screen, so I'm going to have to, but there we go. That is your final answer, okay. Hopefully that was useful for the walkthrough. Of course, any questions you can comment below, and yeah, hopefully that was useful. But thank you for watching, and thank you.